Alright, so this one is solving trig equations by factoring. Factoring. Aren't you guys excited? These are so fun. Alright. That we'd have to factor with these.
That's the reason.
Alright, so we're going to say 2 sine squared x minus 3 sine x plus 1 equals 0. And for this one, we're going to do find all solutions for this one. Okay. So, if this messes with your brain, and for a lot of you it will, let's think of this as 2x squared minus 3x plus 1 equals 0. Is that better? Whew. So that's what we're doing. Like, that's what we're factoring. So when you do these problems, if you want to take out the signs while you work on the factoring part and then put the signs back in, that's fine. As long as you put the signs back in. Some students don't, and then they just get the wrong answer every time. So just be careful of that. Yeah, that does suck. So how do we do this problem? Oh, snap. So we're finding something that multiplies 2 times 1 is 2. So something that multiplies to 2 but adds to negative 3. What are the numbers that would multiply to a positive 2? Negative 2 and negative 1. So now I'm going to break it up. 2x squared minus 2x minus x plus 1 equals 0. Right? So remember the grouping that I showed you guys before? So we kept the beginning part, we kept the end part. 2x squared and 1, we kept those. The middle part we split into 2 pieces. And then what do I do with each of these halves? Factor out the GCF, right? So what's the GCF over here? 2x, and then what's left over? X minus 1. What do you guys think the GCF over here is? Negative 1, good. And then what's in the parentheses? X minus 1. Okay. So, ooh, tricky. So when we when we write this as 2 sets of parentheses, what should we write? Okay. Now, let's go back and let's put signs in it. So this one is going to be 2 sine x minus 1, and this one is sine x minus 1. Students who get these problems wrong forget that step. They forget to go back and put sine in it because this was really a sine problem. Okay. So for the first one, sine of x equals 1/2, right? And then for this one, sine x equals 1. Okay. So now, are these answers that would be on the unit circle? Yes, they are. Okay, so let's look for them on the unit circle. You are allowed to use your unit circle. I don't know where mine is. Oh, it's right here. So where is the y coordinate? 1/2. And where else? And then 5 pi 6. So here's the 2 answers for the first one. And if I'm writing all solutions, then what should I put on the end of this? Plus 2 pi k plus 2 pi k. Alright, so there's my 2 solutions here. Where does sine x equal 1? Pi halves, is there anywhere else? Nope, just pi halves. So x equals pi halves plus 2 pi k on the end. How could you check your answers? Anybody? Plug it back in. Now this one's kind of tricky to plug in. We're gonna practice this one because it's kind of weird to plug in. So 2 sine. Which answer do you guys want to check? Pi halves. 2 sine. Oops. Pi halves, and then I'm gonna hit squared. So I'm not able to type it the way it looks. I can't do sine squared. That's not a way you can type it in your calculator. So this is how you would actually type it. Minus 3 sine of pi halves plus 1. And if we solve that correctly, it should equal 0. Ta-da! Are you in radians? Did you type sine both times? Did you do plus 1 at the end? Oops. So that's what I typed first. And then that part. Do we get it? Oh! Yeah. So sorry.
No, it's okay. Thank you.
I thought you said calculator, not paper. Okay. Alright, let's try another factoring one. Let's try one that has messier answers. Are you guys ready? Okay. Here. No. Okay, here's the next one. 6 cos squared x plus cos x minus 1 equals 0. Okay. What should we do? Yeah. Get rid of those cosines. I don't like them. Okay? So, what are we multiplying to? What are we adding to? Multiplying to negative 6. And then adding to... What are we adding to? Positive 1. Okay? So what are two numbers that would multiply to negative 6 but add to positive 1? 3 and negative 2. So 6x squared plus 3x minus 2x minus 1. And on this one, I'm going to say find solutions from 0 to 2 pi. And whenever this is the instruction, the goal, if you can do it in an exact way, if you can get it from the unit circle, you should. And then if you can't, that's the only time you would use your calculator to get the decimals. Okay, so how do I finish factoring this? GCF of 3x. And then what should I write? Wait, 6 divided by 3 is 2. Okay, 2x plus 1. Okay, what's... Yeah. Alright, what's the GCF over here? Negative 1. 2x plus 1. Okay. So, what are the two sets of parentheses that we have? And 2x plus 1. And then, yeah, here, not sine, but, so, let's go ahead and put cos in there. So we're going to have 3 cos x minus 1 and 2 cos x plus 1. Yeah. 3x minus 1? So you have two parentheses that are the same, so that one gets written down. and then the stuff that's in front of those parentheses, that becomes the other parentheses. So we had a 3x in front of this one and a negative 1 in front of that one. So 3x minus 1. We did the same thing up here. We had a 2x in front of this one and a negative 1 in front of that one. That's where the 2x minus 1 came from. Yeah. Okay, so over here, for the first one, we have cos x equals what? 1/3. Cos x equals 1/3. Over here, we have cos x equals 1/2. Okay, so one of these is going to have exact answers. One of them is going to have approximate answers. Which is which? Oh, negative half. Sorry. I turned around and I saw stressed out faces. I apologize, I missed the negative. My bad. Okay, so what should we do over here? Look at the unit circle. Okay, so let's look at the unit circle and find the two places where the x-coordinate is negative half. What do you guys see? 2 pi thirds and 2 pi thirds and 4 pi thirds. Okay, so 2 pi thirds, 4 pi thirds. Why am I not writing plus 2 pi k? Yeah, I just want to be at 0 to 2 pi. Okay, and then how do I find the answers over here? What should I do? Yeah, so these are going to be approximate. So I've got cos inverse of 1/3. We'll do 1.231. And then how do I find the other answer? 2 pi minus the decimal I just got. So 5.052. All right, 4 answers there. Let's try another one like that. That was so fun. Yeah. So if you think about like a normal factoring problem would have had one answer here and one answer here, but typically we have 2 answers on the unit circle, right? Typically, and so then we would have had 2 answers for this one, 2 answers for that one. Yeah. Okay. We're going to do another one that's maybe not the most fun to factor. So we're going to do 3 tangent squared x plus 8 tangent x plus 5 equals 0. What do you guys want to do first thing? Get rid of the tangent. So 3x squared plus 8x plus 5 equals 0.
We eventually want to use like a tan and a cos in the same problem.
We'll do one of those next so your brains don't explode when you see it. Okay. They're not bad. They're not bad. I'll show you. Okay. What should I do? Something that multiplies to 15 and adds to 8. 5 and 3. Okay. So I'm going to write 3x squared plus 5x plus 3x plus 5 equals 0. I could have switched them. The 2 middle ones. Yeah. It doesn't matter. Alright. What's the GCF of the first 2? X. And what do you get when you take out that x? 3x plus 5. Now this is unique in that we haven't really seen this before. What should you do outside your parentheses if you don't have a GCF? Put a 1, yeah, put a plus 1 right there. Okay, so 3x plus 5. So, two sets of parentheses. What should be in the first set? X plus 1. What should be in the second set? 3x plus 5. Okay. So here I have tan x plus 1, and then here I have 3 tangent x plus 5. So here, tan x equals -1. Here, tan x equals -5/3. Okay. So one of those should be good to look at the unit circle for. Do you guys want to do all solutions, or do you want to do from 0 to 2 pi? 0 to 2 pi? Okay, so we're doing solutions from 0 to 2 pi. So on the unit circle, if we look, where are the two places where tangent would simplify? So y divided by x would be -1. Say it one more time. 3 pi fourths and 7 pi fourths. So 3 pi fourths, 7 pi fourths. Okay, and then what should we do over here? Alright, so tan inverse of -5/3. Should I even write this answer down? No. Why should I not write this answer down? It's negative, it's not in the interval. How do I find the next answer? Plus pi. Okay. So x is approximately 2.111. Since the first one was negative, and this is my second one, does that mean I'm done? No. What should I do? Add pi one more time. 5.253. Okay. All right, let's do one like Thomas said, where what happens if you have a cos and like a sine at the same time. No, I'm gonna show you because they're actually not too bad. We're gonna do 2 sine x cos x equals sine x. Okay. When we factor, what do we want the problem to equal? What do you normally want the problem to equal when you factor? 0. So let's go ahead and make it equal 0. How would I do that? Minus sine x, right? Okay, so I've got 2 sine x times cos x minus sine x equals 0. Yeah. Yeah, do you guys see how sine x is a GCF? You got a sine x over here and one over here? So we take it out. Okay, so if I took sine x out of the first part, what is left over? A 2 and a cos x minus 1. Do you guys see how that wasn't too bad? Okay, well over here, what do we have over here? Sine x equals 0, right? Anytime you have something in the front of your parentheses, that part equals 0. What does cos x equal over here? 1/2. Positive or negative? Which one is it? Positive 1/2. Okay, so sine x equals 0. Where on the unit circle would that be happening? Yeah, we're going to have, and actually, do you guys, we didn't decide. Do we want to do all solutions here?
Yeah.
Let's do 0 to 2 pi because something's about to happen I want to show you. Okay, 0 to 2 pi. So, for sine of 0, we have pi is one of our answers. Then over here we have 0 and 2 pi. But I'm not allowed to write down both of those answers. Can somebody tell me which one I'm supposed to write down? The 2 pi. Why can you not write down 0? It's not included. 2 pi is included, but 0 is not included. So over here we would say x equals pi and x equals 2 pi. If you told me that x equals 0 over here, I would mark you down, because 0 is not included in the interval, even though it's the same spot. Okay, so we are careful there to write down 2 pi specifically, because 2 pi is included. Alright, what would the x values be over here? Pi thirds and 5 pi thirds. Okay. I think we'll call it good there.